Alright, this is the webpage for the UTC Observatory project. This is our home page, and we go over briefly all the concepts that will be found throughout the website. First, we have a quick background, which you'll find more in the background tab. Overview, which is just a really short overview. It kind of touches on the Raspberry Pi and our objective to modernize it. Some of it was straightforward, hardware replacement, which we'll see in this section. Interruptions during observation. Here we quickly talk about a wall-mounted system that rotates the dome. This is a manual switch that we'll see a picture of in a little bit. This dome has a nearly azimuth moving motor that'll rotate on a horizontal basis. So essentially this dome will rotate and then it'll run into the dome. Its line of sight will run into the dome. So there is a dome alignment that we were trying to get, and this is the main project. One of the side projects was trying to get this telescope. There's some fine motors that manipulate it, kind of on these X and Y, X and Y plane. It is at different angles and whatnot, so I guess it's not X and Y. The electrical system diagram is one of the deliverables. So here we can see we have pictures of the blueprints that are here. These are not final blueprint pictures. We are using a TVA Valley Authority AutoCAD program because I have an internship with them. So off time, I'm creating these. This is our overview. This will kind of continue more in the background. So we're going to go ahead and go to background. The Clarence Jones Observatory was started in 1938, 1944, a 99-year lease with the University of Chattanooga took it on. So it's been part of the active curriculum for a while. So what they need to do is they need to make this historical building work for modern class. So unfortunately, they didn't have any information on the electrical system to give us, so we went ahead and we just tried to rediscover the past here. Here we can see that we have a kind of some pictures of us going in here and going in and figuring out what's going on. We replaced some old capacitors that were found in here. We had some exposed copper and kind of some sketchy stuff in this box down here. It's a relay box with more to come on that, but and we had a improperly installed outlet in the corner of this telescope base. So it was actually reverse biased, so it was not good. Everything is DC running out of it mostly, or everything that has been, so no one ever noticed. But electrical legacy, so we don't have to repeat the past of having to create all these. We hand sketched them as we dug in these boxes, and then we went ahead and just redid all of our drawings in AutoCAD. So we'll get these a lot prettier in our final project. Here I like this shot because we have a picture of the dome, and then we have a picture of a schematic. It's upside down, unfortunately, but we'll get that cleaned up. Planning innovation. This is where we talk about the dome of the telescope. Oh, wrong page. The dome of the telescope, where the dome will rotate. Instead of having a manual switch, this very old manual switch, we're replacing it with this new screen. So we're very excited for that. This right here was what they had to stop observing and going and flipping up and down. This is our one of our blueprints. We'll have more with our concepts and design. This is some code, and this is concepts and design topic 2. Here we have just a real quick testing of it. I put this in the background just because in the concepts and design we'll have a video of it being fully and completely finished. So that is not in there yet. Here we can see it's a very short video, but we just manipulate the motor to go forward and reverse. The azimuth calculation or the timing calculation is not on there anymore, or not on there yet, sorry. Ease of use. So that cord was entangled in the way. It's just an older system. Probably going to fail sooner and later. So we went ahead and did a swap for this one. This uses a background on that is something that we're doing. And then further background is the spirit of renewal. So right now they're pouring a lot of money into the observatory, which is very exciting. The first thing that they did is they repainted this telescope. So if we look back at our homepage, we have this big orange telescope, and that is Alex Myers right there. So we were at the observatory during this phase, and we are now at the observatory at this finished phase, well, nearly finished phase. So this is all 100% put together. We have the um, repainting, refinishing, polishing up of the telescope, and it looks mighty good. And then kind of talk about the brick fascia getting remortared. We have that right here. So this is actually, as the recording is being done, the state that the observatory is in. So they have everything taped up, and you're not allowed to move the dome because it's sealed the best that they could with tape and plastic. And then the telescope is very sealed. They make sure that nothing, no debris, no dirt that's floating in through the dome is able to get on the telescope to scratch those very expensive mirrors. This is just another shot before they wrapped it up, and another one. You can kind of see they have everything. You kind of see with the angles and everything they have. Here's one of the motors that the switch is gonna, the RF switch is gonna be able to control. Yeah, and this is what it looks like at user end. So here's that motor on the side. They actually replaced the lights in here, which is really nice. So we have this system over here as one of our blueprints, a system down here that we're calling um, the relay box, and then this system over here that's going to be completely new. Go back to start with that. All right, concepts and designs. I'll try to speed this up. So the good, better, and best. So we talked about our ideal is if we had a stepper motor, we could do a constant azimuth calculation to mirror the Earth's rotation. The slow and constant would be ideal for a stepper, but unfortunately we have a single phase, which would be catastrophic if we died to do that. So with our single phase, essentially we wanted to go ahead and design it future-proof. So our concept and design and programming is all going to be very flexible. So if they do drop a new motor in, we'll hook it up. I'm sure it hooks up in the exact same form or fashion, maybe a little different, but our user face stuff when it comes to the micro and the screen and the override, all that should work very well. And then we just have to get an azimuth calculation dropped in there to get this dome to spin at a slow and constant speed. So that should be very easy if the money was there, but getting a gigantic stepper motor, it would take time and money, and we didn't realize it until a little bit before Christmas, and um, just didn't. That's just not in the cards, unfortunately, for our program. Anyway, so we have it future proofed. This was the first one where we have the VFD, so that would essentially be able to give us the stepper motor design. So underneath here, we'll put in the new, above the safeguard systems, we'll put in the new photo that'll be a picture of the AutoCAD drawing, and then we'll put in a video of it working well. Safeguards, here we just talk about three elements. One, and these are all human elements and environmental elements. We do have some electronic elements and, making it a safe system in our engineering specs. But essentially, we wanted to have the override switch in our system. The override switch cannot backfeed or doesn't, it runs a risk of burning up our motor if I have it in forward on the Raspberry Pi and then someone throws it in reverse using the manual switch. Essentially, what could happen is we power both ends of the motor and burn it up. So what we're going to do is have a CT that is going to automatically cut it. That's what this whole paragraph is about right here. We want to make sure it's easy to use so that way everyone is comfortable using the touchscreen instead of that manual override that we're putting in. Second one is we don't want to give anybody black eyes. We're going to put a little 3-volt buzzer in there so that way it gives some audible warning to let you know that more audio is on the way. Some more noise is on the way, sorry. So yeah, that motor is going to be loud, and if you have your eye up against that telescope and it goes off, make you jump, might hurt your eye. Just a nice safeguard to have in there. The last one is just a simple thing. We're putting a fan in there because it's hot, doesn't have AC. The adjustable controls, that's the one that I talked about right here. Essentially, this guy gets, here I have a better one. This guy gets replaced with this. Essentially, black wire goes in here, and it is the switch leg, and then we have the hot that comes on that side. When you press it down, it closes the circuit. We have a normally open connection, and then the common, and we'll just put the hot on the common, normally open on the switch leg, and then this thing is just a easy low hanging fruit upgrade. So that's what that says. Didn't take much effort at all. That's why we didn't write much about it. Engineering specs. We tried to gather everything in our baskets and put it here. Some of this stuff is going to be design implemented, where we have things where we want to make sure that we have like a safe mode if the relays are off on a crash. Want to make sure that things can be overridden with this manual override. And protective enclosure, stuff like that. But some of this is going to be rated voltage and rated current, mechanical lifeline. This is just engineering specs that come with the equipment that we're using. And the last page is our contact us, where we have our contact information. Down here we talk about, I just wanted to put a nice footer in there, so I don't know if you noticed, but that's on all of them. So essentially what it says is that this is the social media, this is a historical website that UTC owns, this is Facebook, this is Instagram, this is saying that you can't go by yourself, and that the Clarence T. Jones Observatory is owned by University of Tennessee Chattanooga, or property of, with the rental agreement. So that is all that we have for our website. It will be updated shortly, and that's all we got.